Well, welcome everyone. Thank you for making the time. This is an exciting year 4 Science and Practice webinar series, Forest Climate Change Initiative, co-hosted by the University of Maine Center for Research on Sustainable Forest, the Forest Stewardship Guild, and the Maine Tree Foundation with support from the Munsunken Fund. We have an exciting agenda today. Hopefully folks were able to join us for our last webinar, which was a really great field tour and I think really insightful of the role in fire. Today we're moving a little bit further north and talking about the value of long-term research in this region. And we have some great guests that cover the span from scientists to practitioners that we'll be sure to touch on. There are spots still available for Friday's field tour. Looks like a sunny day before we get some 50-degree weather and rain. So hopefully you can make available. We'll drop a link in the chat if you're able to join us. First, I just want to do our land acknowledgement statement. We respectfully acknowledge that the Wabanaki, the people of the Dawnland, are the original stewards of the forest we discussed today. The University of Maine is located on Marsh Island in the homeland of the Penobscot Nation, where issues of water and territorial rights and encroachment upon sacred sites are ongoing. The University Center for Research on Sustainable Forests supports forest research and education in the homeland of the Penobscot Nation and other Wabanaki tribal nations. We strongly support the inclusion of Indigenous science and values in forest stewardship, management, and research. And I'll gladly say that we just submitted an NSF grant today that would further this whole mission and really bring traditional ecological knowledge to many university faculty in Maine. So exciting opportunities. With that, I'll turn it over to Amanda to introduce our speakers, and Meg, if you want to launch our first poll, we'll get going.
Awesome. Thank you so much, Aaron. And I'm really glad to hear about that NSF proposal. So you should see a poll in front of you. This will help our speakers get a sense of who you are and where you're coming from, what background brings you to this meeting. And I'm also curious how many of you are excited about watersheds and long-term data. Long-term is relative when you compare it to knowing ways of knowing since time immemorial, but there's been a lot of good research in the last several decades at Bear Brook, and we're excited to learn more about it today. I see I'm going to give folks another 5 seconds to complete the poll. 4, 3, 2, 1. Bink. All right, and Meg's about to share the results. So for folks that are on the webinar today, most 7 out of 10 are from Maine. Approximately a quarter are from somewhere in New England, and then someone else is from somewhere else in the US. About half of you consider yourself a forester in your role here today. Almost 30% say you're a scientist, and we have another 4 folks that are in a kind of conservation related or a natural resources field. Let's see. So, we have a few first timers on today's webinar, but we've had some folks that are repeat customers, and we're really glad to have you today. All right. So Meg is stopping sharing. So we are going to be, so now we have another poll for you. So please take a moment and let us know, how familiar are you with forest hydrology and best management practices? And are you familiar with the Bear Brook Watershed and the research there? And just a hint, I can probably drop in the chat the link to the information page, but there are a few Bear Brooks. This is the special one with lots of long-term research that you're going to learn all about today. So I'm going to give folks another 5 seconds to complete this brief poll. 4, 3, 2, 1, bink. All right, so let's see. How many of you are familiar with forest hydrology and best management practices? Over half of you are at least somewhat familiar, and some of you are very familiar. And just as a note, our speakers can't complete the poll, so this is good. And some are just a little familiar, and others are not at all, but that's okay. So how many of you are familiar, or how familiar are you with the Bear Brook Watershed? Not many of you are very familiar with it. So you're going to learn a lot today, and it's really cool and really exciting. How likely would you be to implement management based on findings from long-term hydrologic research? Over half of you say very, and the rest are basically in the some camp. So if you have the opportunity to learn more today or on Friday at the field tour about hydrologic research and best management practices, you're going to get a lot out of it. So without further ado, I want to turn over to our first speaker, and they're going to segue from one into the next. We'll hear from Ivan Fernandez, Sean Smith. We'll also hear from Mike, and then Mike Howie, and then from Jake Metzler, all presenting a different picture of what we will see at Bear Brook this Friday. So Ivan, please share your screen, and we look forward to hearing about all the cool stuff going on there. Thank you.
Can you see it, Amanda?
We got it.
Okay. Well, great. And thanks for the opportunity to talk a little bit about Bear Brook. Amanda lied. You're not going to hear all about Bear Brook because we could go on forever. And I think my charge here is in the next few minutes to give everyone a little bit of background of why Bear Brook exists as an experimental research site. So I'll jump right into it. The origins of Bear Brook are really rooted in environmental policy. It's focused on study of acid rain effects on ecosystems, particularly forested watersheds and surface waters related. Probably the first conference on acid rain in forests here in the U.S. was in the mid 1970s. I think it was 1975 in Ohio, actually, which by 1980, we had a national program of research that was designed to inform what Congress needed to do in reauthorizing the Clean Air Act in 1990. Sort of the simple version of the key question here would be that they were asking, how much should we regulate air pollution to protect natural resources in the future? And of course, in the future is the really hard part. And so it was the need to answer that question that brought about the national program, and that brought about Bear Brook. How do you answer that question? Well, you can answer it with models. I'm not a modeler. Some of my best friends are modelers. All models are wrong. Some models are useful, is the old adage. They're really useful, but they need to be informed by the basic science of how our world works and how ecosystems work. And there's kind of three ways to answer the question from the empirical science side of how ecosystems will respond in the future. One is long-term monitoring. If you're doing long-term monitoring, you can look at the historical record, and from that conjecture how the future may unfold under different conditions. And you need to keep on monitoring so that when you get to that future, you can determine whether you were successful or not. So that's a real important component. There's research that substitutes space for time, which we also did those studies here in Maine around the acid rain and air pollution issues. And that's where you establish research under different conditions that are being naturally exposed or perturbed at different levels of intensity or exposure, and develop the understanding of the relationship of how systems are responding under those conditions, and assuming that the cleaner site, for example, might behave the way the cleaned up site will in the future. Always artifacts, but nevertheless, we learn a lot. And then the third is really what brought us to Bear Brook, and that's doing experimental manipulations. Always fraught with artifacts experimentally, and yet we also can learn a lot from them, keeping that in mind. And so Bear Brook is a whole ecosystem, whole watershed, experimental manipulation that was designed to contribute to this body of knowledge. All of that feeds into models, and those models are in fact the underpinning then of policy development and other ways of looking at alternatives to management and policy levers that we have control over. The timeline for the development of Bear Brook, 1980 to 1990, was that national program, the National Acid Precipitation Assessment Program, NAPAP. There was an interagency, federal agency task force that oversaw the national acid rain research during that period of time. Keep in mind that acid rain is are co-pollutants with carbon from burning the same things that we're still talking about, certainly from the standpoint of climate change. By the mid-1980s, there was a plan that hatched, led by EPA and with Forest Service and others involved, to develop 5 whole watershed experimental acidifications in the U.S. Long story short, only one was developed, and it's the Bear Brook one. They came to Maine for a couple of reasons. They knew of us, scientists working in this area, but we weren't all that famous that they would come just for that. But we're also in Maine. We're at the end of the pipeline relative to exposure for acid rain. We had certainly higher levels of acid rain back in the 80s, but nothing like the Adirondacks or the Southern Appalachians, which would have much higher deposition. So Maine offered a place where you could have a reference system that was less polluted, and then treat a companion system in order to look at the response. In 1986, we surveyed 70 sites throughout Maine, doing water chemistry and bedrock geology and vegetation typing and so forth. And by 1987, we decided on Bear Brook for a variety of reasons. Bear Brook's located on Lead Mountain, and we never call it Lead Mountain because if it had lead ore in it, that would mean it's a lead sulfide, and the sulfur from that weathering would ruin the experiment. We checked it; it doesn't have lead sulfide ore, just in case anyone's curious. But in order to keep that controversy out of the scientific literature, we've called it Bear Brook Watershed in Maine ever since. And there's a number of Bear Brooks, so that's why we call it Bear Brook Watershed in Maine, BBWM. 1987 to 1989, we did a pretreatment calibration period to compare particularly the behavior chemically and hydrologically of the 2 streams. At the very beginning of the whole watershed experiment, we did an external plot experiment for about 5 years in order to do some short-term science to deliver some early findings. Remember I said the Clean Air Act was to be reauthorized and was reauthorized in 1990. And so we were just starting really the experiment at the whole watershed level in 1989. So we were going to provide very limited new science in the early years there. And so the EPE was designed to do that. It was outside of the watershed, and we can point out Friday where that was located. And then in 1989, November, we started to treat the West Bear watershed compared to the East Bear watershed, the reference, and we treated it for 26 years. In 2016, we stopped treatments and began to look at recovery. So the site is located here on Lead Mountain. That's a cell tower at the top of the summit of the mountain that some might recognize. Lead Mountain is one of 3 points that were used for early late 1800s geologic surveying. There's a marker at the top of the mountain for that. Others are on Scudic Mountain and in Acadia, and they would triangulate from those peaks. The 2 watersheds are laid out clear on the side of the mountain. You might be able to detect these 2 little divots in the forest, and we will look at that in a second. But for those who may be unfamiliar with the watershed concept in this context, that means that every drop of rain or precipitation that falls on this area drains through this point, and likewise for the West Bear watershed. And these divots are where the weirs are. I don't know why this clip doesn't work. So the reference watershed is East Bear, the treated watershed was West Bear, and both of the streams, first order streams, are gauged by these V-notch weirs, the gauge house, and precipitation collectors next to it. And Sean can tell you all about the details of hydrology. We treated West Bear with ammonium sulfate by helicopter every 2 months for 26 years. began in November 1989. The rate of treatment was 25 and 28 kilograms per hectare per year, nitrogen and sulfur. The 1800 equivalents, for those that forget high school chemistry, was the treatment loading was actually calculated on an equivalent basis because of the acidification mechanisms that take place. And so this made it similar or comparable to more heavily polluted systems in other parts of the eastern U.S. The treatment stopped in October of 2016 for the 26 years. The idea of these experiments is that you have a black box and you can control and measure everything that goes in and everything that goes out. And so you understand then the processing at the macro scale that the ecosystem is doing. This is actually John Cangelosi, a teacher at Bangor High School now, back in his younger days. And on here on the catwalk is a Belford rain gauge to accurately measure precipitation, an Aerochem Metrics wet-only precipitation collector that we would use to collect for precipitation chemistry. It would close when it wasn't raining, so that we would not get other debris into the water sample. We'd sample up from the stream using manual samples and ISCOs for periodic sampling, and we'd measure the hydrologic flux here. For several decades, it was done in conjunction with the USGS here in Maine, and this was the smallest gauged catchment in the state at that time. Of course, most of the action and most of the money was actually spent on understanding, the mechanisms of response for trees and forests and soils and microbes and atmospheric deposition and you name it inside the box. And so much of the millions of dollars and hundreds of students that were involved in this research were involved in those various specific studies that helps us understand the changes that take place and also drives improvements for models in order to understand how the model should parameterize what actually is happening in the field. The only data I'm going to show you today from Bear Brook are these two figures from a recent paper by Kaizad Patel. He was a PhD student of mine, and now he's at Pacific Northwest National Lab. And these are the chemistries of the streams of West Bear and East Bear over the 20-some years of monitoring. On the left is sulfate, on the right is nitrate. And what this is showing you is the concentrations of sulfate in East Bear and West Bear streams were pretty similar at the very beginning. And this was the pre-calibration period where we evaluated how well they compared, and they compared pretty well. And then we began treatments in November of '89. The East Bear reference continued unperturbed. And what you're looking at here is the benefits of the Clean Air Act, as sulfate naturally declined in surface waters everywhere east of the Mississippi as a result of controls put on sulfur emissions from the Clean Air Act policy. This is the response from our treatments. We treated with ammonium sulfate, so no surprise that sulfate increased. One of the various kinds of insights that you get from this type of research, the models that were primarily being used by Congress to evaluate policy options at the top or at the time were predicting that sulfate concentrations for our experimental loading should peak out sort of up here around 300 microequivalents per liter in the streams. When a decade later, we found that that was not accurate and they peaked out more like 200 microequivalents per liter. So that's a good example of where we were, are then able to apply the science to improve the models that are essentially still used today. Both of these curves continue to go down because the background sulfate concentrations are the baseline that's going down. When we stopped treatments, not a lot changed. Sulfate is going down, but it didn't dramatically decrease. And that's because the sulfate, excess sulfate from our treatments are slowly going to bleed out over a longer period of time as chemical equilibria comes into play. The same with the ambient. And so this doesn't reflect the sulfates coming in from the atmosphere. This mostly reflects the slow recovery of primarily sulfate absorbed in these forest soils. For nitrate, we don't have time to get into that, what was happening back in the 1990s there, but basically very little nitrate comes out of these watersheds. They're nitrogen deficient. When we added ammonium, it was quickly, it actually, a couple of mechanisms there, but nevertheless, nitrate quickly increased, very noisy, but stayed elevated throughout the study period. When we turned it off, it immediately recovered. These are nitrogen deficient, so they would retain that nitrate. That's not to say that much of the nitrogen that was added is not still in that watershed circulating and will be for decades to a century. We also have a stable isotope 15N in both watersheds that one could track if they wanted to. And so, concluding thoughts here, long-term research is even more important during a period of accelerating environmental change as we are experiencing now. And these kinds of data are critical for cost-effective decisions on management, on policy, to evaluate both our successes and our failures. The big advantage of long-term research is time is on our side. So with that, I'll turn it over to whoever's next.
I think it's Sean's turn. Oh, thank you so much for that, Ivan. Very exciting to hear about sulfates and about the results of that research. Sean, if you want to go ahead and share your screen, then we'll get you up and rolling. Let's see, we'll go into presentation mode. Oh, we got to do that. Yeah, there we go. Flipping the display. There it is. All right, rock and roll.
Okay, can you hear me?
Yep.
All set. So today I'll just cover in the shortest amount of time I can manage Bear Brook experimental watershed research and education activities. I haven't been here as long as Ivan by far. I arrived in 2011, and I found it to be a very productive place to actually introduce students to watershed hydrology and process and fluvial geomorphology research and applications. And my affiliations are interdisciplinary with School of Earth and Climate Sciences and Department of Civil and Environmental Engineering, and I'm part of the Maine Forestry and Agricultural Experiment Station. And a lot of the work that's been going on there is through our the project that I have at MAPIS, or the Ag Experiment Station, over the last 8 years or so. Let's see if I can get this to roll. There we go. So what I'm going to talk about today is two major parts of this story for me are use of Bear Brook experimental watershed with students in coursework, a lot of different classes, and also which I believe is a big part of the ambition to have research learning experiences and to prepare them for the professional world with applications, but also instruct on the background concepts. And so what I have here is just a basin diagram of Bear Brook, not only in the experimental watershed, if you can see my cursor, that has East Bear and West Bear with the two gauge stations that Ivan has talked about, but also the portion of the watershed below it that goes down to Bear Pond in the lower right-hand corner of the figure. And what you see on the right are some of the topics that we capture, both in research and education activities: surface water flow regime, an analysis of the flow regime, terrain roughness, and what's because it relates to surface water hydrology, and also the processes that Ivan has been talking about. And I know that it has interdisciplinary applications for land management as well, including forestry. Then also stream channel forms and stability, which is more closely associated with my deep background in fluvial geomorphology. What basically is happening to the streams and how do they change over time? And then sediment yield, what's coming out of these basins in response to climate and land perturbations. So for teaching, I just have a list of courses there. I've highlighted a few of them. There were also guest appearances and others, and guest trips with students. Basically, most of the work has been done in freshwater flows at University of Maine, And we use the gauge stations that are in place and the records that they have to do exercises on hydrograph development and also interpretations of the hydrograph in terms of runoff and base flow contributions to those hydrograph signals. So it's a really good resource for that in comparison with two side-by-side watersheds. One of the targets that we've been looking at in research with students is our hydrologic signatures. This is just a set of 3D plots that include actually Acadia National Park, but some of the focus for Bear Brook is the same, where you look at the day of the year in the data time series, and also the discharge in the vertical axis. And you can just see these signatures that show up, or kind of the hydrologic fingerprint of these systems. And we've been working with students to show how these are broken down and appear differently in different settings, including Bear Brook. And this also is a part of our research in a larger context in the Maine in responses to perturbations in the watersheds and climate change. So for the coursework that we've done, a lot of it is focused on single hydrograph storm separation, or a hydrograph separation, where we take a time series from the gauge station and try to find the contributions from base flow and direct runoff. We run students through these exercises with the data we download from the stations. They get a lot of experience working with the time series, but also with the calculations. And what I'm showing here is just this hydrograph that was about the time I showed up in August of 2011. These values aren't very high on aren't very large on the y-axis here in cubic feet per second, but they're basically showing the increase from this precipitation event on the upper x-axis, and the contributions of runoff increasing all the way to a peak, and then the drain out of the watershed after the storm. But you see this dash line here, which is actually the signature that corresponds most closely with the Bear Brook Watershed hydrograph, not only this one, but others. And what it implies is that a large portion of it, all this portion under the curve that's from D down to B in the time series, is actually subsurface flows that's carried through. And that's a big concept for the students to grab onto. So we take that data and we also do a modeling exercise, which we've also fed into some of our work there for research. And you can see here again a schematic of the watershed. We break it into sub-watersheds. Here are the two gauge stations we can use for calibration. We use this all the way down to the outlet at Bear Pond to simulate the watershed processes. This is a map just showing surface slopes and how they're changing with the legend here down in the lower left. We also use that slope information to develop flow lines. And so they have experiences working with spatial data. We've also used this for our research, which we'll talk about in a minute. We use land cover data to parameterize for runoff production and hydrologic soil groups throughout the basin, all the way down to Bear Pond. And here's the target for students. We have them run through USDA software for watershed modeling, where we put in land use, the flow routing information, and we develop these scenarios in the East and West Bear for different land cover types. We actually take the land cover and change it to townhouses on one of the watersheds, and then we compare the outcome, and then we put a pond in at the bottom end. So they get a lot of experience in playing with these knobs sort of in the watershed system. In the research side of things, this has been built into my MAFIS project, which is focused on headwater patterns, practices, processes in central and coastal Maine. And you see Bear Brook here in the upper right-hand corner. What we've been focusing on is comparing conditions in these different places. And a lot of that in Bear Brook has involved a lot of ground truthing and looking at terrain conditions with students. And you can see here this LiDAR image that shows the stippled nature of the terrain here. We actually went up and looked at where channels begin in the watershed and tried to explain why those initiation points exist at the top of the drainage networks, and also the conditions of the channels as you go further down towards the gauges in the step pool configuration shown in this longitudinal profile just up above the gauge station, which Ivan has already shown here. We also look for the places where there are inflections in the topography, which actually show up as spring seeps in different periods of the year, and also the terrain in terms of divots in the landscape, which we've done more work on. And we work on looking at these for spatial data analysis to actually show the profiles that are associated with an aerial map in different transects across the basin. More recently, in the last fall, in the recent fall, we published a paper on remote detection of upland surface water storage capacity in deglaciated terrain. What we're noticing in our modeling exercises where you have to have usually a literature value for depression storage, it shows up basically as puddles. And these puddles are actually, whoops, let's see if I get back to that, are often the result of tree fall, which we see in Bear Brook Watershed. This is a picture here taken in the watershed. This is actually in Orono, where I'm standing next to a large tree fall that caused by a windstorm. And what we were noticing from the use of LiDAR data is you can really show terrain roughness changes with land use, not only urbanization, but also just cropping and plowing. And so we started to get interested in this and use Bear Brook as one of our sites here, site number 2 in this state map that shows the comparison of depression storage across different landscapes, because we were worried about using literature values from other places. This involved a lot of terrain analyses with looking at individual puddle depths and what caused them, but also the relation to mean depression storage depths and the relation to slope, which is really critical on Bear Brook because there are slope changes as you go from the high points to the low points in the watershed hill slopes. And you can also see the tilt of that and how it affects storage capacity. Meanwhile, we've also been interested in runoff moving down and stirring up sediment and moving it down slope. This was inspired by a comment from Ivan a long time ago when I first arrived here about the limited movement of sediment in the landscape. And I kind of, despite the fact that it was small, I wanted to find out what it might be. And so we started to work on our terrain analysis and hydrologic work again. And we focused on the stilling wells at the bottom for the gauge stations and where they accumulate sediment to see if we could estimate yield from these catchments in annual time periods. We also went down to the pond down at the bottom end and started taking cores and looking at the bottom architecture just to look at this. We took this seriously. We took samples out of the stilling wells and added up the volume of mineral sediment that was deposited in there over a 2-year period. We'd like to go back and do that again. We did work on the photographs of the lake bottom and also cores in those areas, and trying to get a handle on what's accumulating over decadal time scales and longer in Bear Pond, and how that relates to what we see in the upper basins in the stilling wells, and how that relates to what we're seeing for calculations and estimates of transport in the upper watershed. So basically, what I'm getting at is that teaching and research has been vibrant in my hydrologic research group in the watershed process and estuary sustainability research group at UMaine. And we have a lot of different stakeholders and collaborators that an interdisciplinary research that's going on in conjunction with that. And I don't know, Ivan, did I make it in my 5-minute interval? I'm not sure. So.
This looks amazing. Oh, brings me back to my days of TAing hydrology back in grad school. Thank you so much for that, Sean. I think in the interest of time, we'd probably better segue on, and Mike is going to tell us a little bit more about the specific management history at this property. So, so Mike, you got to unmute. Let's see. Find the unmute button. There it is.
Thank you. Thank you, Ivan and Sean. It went fast, but it's scared to realize this May I'll be celebrating 30 years working with the same land base in a number of different land managers and landowners. At the time, I started with Champion International on to International Paper. They had spun that off to SFT, and ultimately SFT sold that to the current landowner. Well, actually, GMO was landowner, but currently it's held by an entity name of BBC. As an employee, I've working for American Forest Management, that is the land manager. I kind of want to make a clear distinction that AFM doesn't own any land in the country, really. We're a consulting firm. It's often a confusing point for a lot of people. They think AFM is the landowner, which is not the case. But really, I'm here to listen, to kind of see what progress or what changes are coming about in the research. I just want to take a brief opportunity just to explain a little bit more about AFM for those that probably don't know. And if anything to take note on that first slide there was just the website of AmericanForestManagement.com. Pretty simple. But on the next slide here is it doesn't represent the scale as far as specific tracks, but it kind of just depicts the states where AFM has managed land clients within it. Obviously, in the Northeast, Maine and New Hampshire is my focus. But AFM started in the South of the United States, and it's headquartered in Charlotte, North Carolina. But back in 2011 is, I believe, I became an AFM employee. We can move on to the next one. And a little more preclude of what AFM is about. I mean, we're a land management consulting. We also offer forest inventory, data management, wood accounting, forest carbon, agricultural services, primarily in the Southeast, and wildlife management. We also have an arm of, we call AFM Real Estate, that we help clients for acquisition and disposition of property, as well as appraisal services on real estate. But honing down, as you can tell, I'm honing down to Bear Brook itself, but the map here depicts my world. We're broken down into two districts. One we call the Milford District, which comprises of the east area and the central area, and over on the western part of the state, based with an office in Farmington, it is our Farmington district. Matt Jacobs is the district manager over there, and where I'm the district manager here over in the eastern part of the state. Housed in those offices, we have client foresters that range from the BBC client, but as well as other small to mid-sized clients, and or to landowners with 10 to 40 to 100 acre small woodlot client. In each office, we have a technical presence, but I think many of you are probably familiar with Jeremy Miller. He's our technical manager, and I think he sits on the CFRU board, and he does plan on joining us this Friday in the field. And beginning of the call before the webinar, before this started, our region manager, David Cole, who many of you are familiar with, he will be retiring at the end of 2024. So that's kind of I'm happy for him, but it's kind of unnerving realizing, ooh, I'm getting older. Anyhow, moving on to the Bear Brook map. It's kind of centered in the screen. I drew a circle just for those not familiar with the area. The green represents the Malone property, or BBC, and really many of you will be going out on Friday down Route 9. And to the north, there's a road that's kind of highlighted that runs east to west. That's known as the Studman Road, just to orientate you. I do recall, I think it was 94, 95, somewhere around there. There was a proposal. Ivan, you probably give a better testimony of the exact history, but there was a proposal for a ski resort lodge from the local community on Lead Mountain. I learned something today that I always wondered why they called it the Bear Brook Watershed, and Ivan, your description was perfect. But I don't know the timing. It seems like the research was going on before my time, but I think at that time, due to the ski resort, is probably when we entered into some sort of lease agreement to kind of tie up this area for research to kind of thwart any other land development projects that would disrupt what's been going on out there. I think those leases were in a 5 to 10 year period, and in 2021 is when the current lease expired, and I believe Ivan was considering retirement, but he's here today. And the Bear Brook research had concluded, and we were faced with, do we revert this lease area back to regular land management that's been, in the that matches up with many of the surrounding areas. So I was faced with that dilemma, and I went back to John Malone is the owner of this property. One of his governing tenets was don't change the traditional use that has gone out there. And I saw this as too good of an opportunity for future research to just let this quickly fade away. for really a short-term gain. If there's some available timber to harvest in the next 3 to 5 years, I kind of gave it pause, and we renewed a lease with the university with the understanding that what kind of new research can come about moving forward. And I know that lease expires in 2024, and that underlying reason why I'm on this call and looking forward to Friday. And one final thing about Malone and the BBC landowner is that they're a friend in the conservation community, high net worth individual that does support many activities such as this one. Project Share is another one. I believe we'll be visiting that, the Naguagas River for Atlantic salmon habitat restoration. The underlying tenet that he has given is that he doesn't want to be brought into the public spotlight with this. He would rather have the research or the habitat restoration kind of draw the attention to themselves and let that stand for itself. So I do admire his humility for making his lands available for this kind of thing. Really, what benefits BBC for continuing these kind of projects, it has to do with their SFI certification, to kind of state that, hey, we're collaborating on forest health and research, and as far as for the long-term mission of the forest products industry itself. So I think that was kind of just the overview I wanted to give. I'm here to listen, and thank you.
That's great. Thank you so much. And Mike, you set it up perfectly for Jake, talking about conservation ownership. So Jake, take it away.
All right. Thanks, Amanda. I'm going to share some slides. I'm going to be quick so that we can get to questions from folks. All right. Yeah, so thanks to Aaron and the team for inviting me to speak on behalf of the Forest Society of Maine and what we're all about. And while we don't have any specific conservation projects immediately adjacent to the Bear Brook Watershed, we've worked actively throughout the region, and I'll talk about that. But one of the things I wanted to highlight is why this work is happening and why it's kind of taken off, and why we're here to play the role that we are, to tie this back to something that Ivan mentioned and that he's been heavily involved in, the Maine Climate Council report. Maine Won't Wait noted, the amount of acreage we're losing in the state of Maine each year to development is pretty impressive. And going out this Route 9 corridor, we'll see it on the field trip on Friday for sure. And so we've done some projects out there, and this is, it may feel remote where we're headed, but it really isn't. So if you remember from Mike's map, this project is in this dark area, kind of east of Bangor, but in northern Hancock County. And this is kind of the pattern of development now. And when I show you in a couple more slides, you'll see kind of where we as a collective conservation body of organizations in the state have had success, and why that's important to this this whole topic. So that's the existing. And as Mike and others have mentioned, we kind of plug along day to day and with our jobs and life, and don't realize the changes sometimes that are happening. And here's just an example of how fast changes can happen. You may have seen it in your life, but here's some data to show what's going on over in Oxford County, which is a pretty rural county overall, and this trend tracks across all the Maine counties. Is starting basically with the pandemic, the amount of real estate transactions and therefore surrogate for development and potential development has surged. And it's important for entities like us to be looking at the long term and the big picture as we work on projects, to try to ensure that the important places and watersheds can be maintained out there for all the benefits that they provide. and that this is one reason why we're here. So how does FSM do our work? We focus on promotion of conservation of forested landscapes that have multiple social values, whether that's economic or jobs for people to work in, or products that can come out of the forest, but also ecological values such as water quality, habitat connectivity, and just wildlife habitat and rare plant sites. So we're always looking at that as we work on projects. So similar to Mike's map again, here's the statewide. The green projects are projects that we've helped complete. And the area that Mike mentioned is just south of this star that's near Nicotawis Lake. And so we've worked to conserve almost 1 million acres, around 1 million acres here in Maine, but you can see lots of other conserved land out there as well. So why do we focus on conservation and the primary tool that we use, which is conservation easements? The biggest thing is that, similar to what Mike just noted, not all landowners are necessarily interested in selling their land for conservation. They enjoy the benefits that come from owning and managing land, but they're not necessarily interested in development or other opportunities that could come along. And development, when I say development, it's much more than just subdivisions for houses at this point. It's wind farms, it's solar arrays, it's transmission lines. There are all sorts of other, there's mining, wells for water, commercial water development. So there's all sorts of things that could be options for landowners that they run the gamut of what they're interested in. But many of the traditional landowners that have been here in Maine are excited to continue to manage for forestry. And that's what we try to focus on, is those landowners that are interested in that and want to see the value in ensuring that forests can stay out there as forests. And so we use this tool of the conservation easement as a way to prevent certain activities, but to allow others. And so that's one key reason why we utilize that tool, whereas other conservation groups use other tools to help meet their missions and address conservation questions. So, as I mentioned, easements across the landscape can connect conservation of fee-owned parcels and Wabanaki ownership to ensure current and future habitat connectivity as things change, and then to build that climate resiliency for the planet. Ensuring those trees are out there, sequestering carbon and storing it for the long term is a key tenet that we're trying to ensure. And then ultimately, easements may not be full fee ownership where we would have total control over what can happen on the land. They are legally a strong tool that will ensure that lands can stay managed, open, forest for lots of different values and not be weakened as things come up in the future. And so I just wanted to show this slide related to that, some in that what you see here are the major watersheds of Maine and the intersection with conserved lands, but also the pink lines are the smaller sub-watersheds. And you can see that a lot of the conserved lands that have successfully been put into place are at the upper ends of some of these watersheds to help ensure that some of the most valuable streams are being protected in a way that will ensure that they stay forested. And what is interesting is how we utilize some of this information in selecting conservation projects. Is there's great value in working to ensure these watersheds stay clean and clear and forested as much as possible to ensure that all the values that we expect from our water are maintained going forward. So my last couple of points here, the map that I showed you is about 4 million acres of conserved land in Maine. Along, you can also see the orange is the Wabanaki held lands. There's going to be more lands conserved in the future. There's great buy-in to the values of that. And using easements, which is what we primarily do, is one of the most cost-effective tools for doing that and ensuring that forests stay as forests, and we can continue to have research efforts like this out there and successful implementation of that research through the management of the forests. And so I will stop there and open it back to Amanda to tell us where we go next.
Thank you so much, Jake. I think Maddie's going to pin all of our speakers, so please turn your cameras back on. Sean, Ivan, come join us. Mike is already there. Wow, thank you all so much. So for all of you out there in the audience, this is your chance to put your questions in the chat, and we'll be able to address them right now. While you're typing your question, I just wanted to reflect back a few take-home thoughts that I heard from those really excellent presentations, and thank you all for keeping us on time. It's hard to, like Ivan said, we could go on all day. But what I'm taking from all this is that Bear Brook is important for the science that it has produced, the sulfate studies that Ivan described as one example, but it's also important for the science learning that's been imparted on the next generation, as Sean described. And also, as Mike and Jake were outlining, in the 40 years or so of Bear Brook's existence as a study site, and even in the last 20 years, land ownership and management practices have changed significantly around the state, and that has a huge impact on the forests that we all know and care about. So just looking to the future, as the climate continues changing and impacting Maine, we have a great opportunity here to learn more from long-term studies in this watershed. Those are my take-home thoughts. And either people aren't typing or you're just blown away by the presentations and haven't figured out your questions yet. I'm going to keep an eye on the chat box, but I have one in my back pocket for Ivan and Sean. Have some of your students gone on to apply lessons from Bear Brook in their professional careers?
Short answer is yes. We've had maybe we've tried to guess what the number was. 150 undergraduate students that have been employed in various aspects of it, and then a whole bunch of graduate students, of course, that have done research. And sure, I mean, the one I showed you a paper of, he's a research scientist at the Pacific Northwest National Labs. We've had them go into environmental consulting and policy and state agencies and you name it. So a lot of people are alumni of the Bear Brook project, and Sean's kept that tradition going with his crew that he can speak to.
Yes, definitely. A couple students are working with state agencies now. One of them in particular that spent time out there in the field on one of the research, I'll call them expeditions with students. When they were interviewing, the supervisor that was interviewing this person said that their field experience and their working with equipment in the field was one of the things that got him over the top on the selection process. Another student, at least two of them are working with the transportation agencies, one with USGS, one has been as far away as Nepal looking on water resources at a basin scale. And so and several have gone on to graduate school and graduate studies at other institutions. And some of them have continued with graduate studies here. So I would say it's pretty successful in terms of research learning experiences and what the intention is.
Very cool. Thank you. I'm surprised the chat box isn't blowing up. I love hydrology. I'm going to turn to Mike with a question. So, based on your time, in and around the watershed, what are some of the, I guess, what are some of the things that you have learned just from spending time there and knowing about the work that's been going on there over the decades? What do you take away from the site?
Really, to follow on Ivan's lead, it's just kind of monitoring the progress of some of the transfer of information, the transfer of some of the materials across the site, that it's pretty stable. But as far as what I'd like to see maybe in the future is a comparison, a similar comparison to maybe in the working forest environment as another set of control. You have a great natural control. I love the logic and layout of the study, but what can we learn from, in the working forest environment? Is there any differences? Is erosion and sedimentation an issue on the remaining 1,000,000 acres for this particular client.
Well, thank you. Yeah, good thoughts to consider. And I'm sure we're going to dig into that more on Friday on the field tour. Jake, if I can toss a question your way, thanks for sharing all those maps and more about the Forest Society of Maine. As kind of a big picture land conservationist, with obviously as a forester, what important lessons do you see from Bear Brook for thinking at that landscape scale and through the conservation lens?
Yeah, I think it's one of the things that I would say I take away is that, it's amazing to me to learn about the different values of the processes at the small scale and the large scale and how they all work together, and try to make these connections of conserved land to help ensure that all these processes can continue to occur at all those different scales. Is one of the things that we look at with projects is, it's great when you can say you've conserved X number of acres, but when actually in the background that one particular watershed is driving, what can happen further downstream in such a way, or that ensuring that it's not developed in a way that could compromise other parts of the system is just key, and as we there are things that we can't control for sure of what's coming into the state through the air, but we can definitely work to ensure that what we have here can stay here, and that's what our biggest takeaway from all of this is. I would say is that it's great research that's been done, and it helps. I'm not the one reading the scientific articles to find out all the different treatments that happen and how they affected, but the big picture take home is pretty clear that having these forested spots is key to helping ensure this water continues and provides what it needs to for all of us to enjoy in all those different ways.
Awesome. Thank you so much, Jake. And that kind of ties us back to what you ended with Maine Won't Wait, and what Ivan started with, which was Clean Air Act and policy from decades and decades ago. So for any of you, do you have thoughts for what climate action Maine might want to take based on what we just talked about with watersheds and with Bear Brook, and the potential for learning at a site like this?
Well, you opened that door, so I'm going to step through it. I think one of the lessons that I like repeating about the Bear Brook experiment and the science that it's about is that it's a beautiful succession of doing science and investing in the science that then informs policy. Policy was developed from that in science, so it's science-informed policy. And I was on a panel for EPA in 2011, I think, that panel that evaluated the efficacy of the Clean Air Act from an economic standpoint, as well as obviously the ecological. I wasn't there because of economic expertise. And it paid back to American society about 30 to 1. So every dollar we spent in the Clean Air Act cleaning up sulfur, and this is really just on the sulfur side, paid back. The range was 9 to like 90. With the median being $30 to 1. And we see that over and over again with lead reductions and ozone and particulate. And we see the same thing in climate action. As we apply the best available science, it immediately is a cost for some of the transition. But if it's science informed, it is inevitably cost effective over and over again. And of course, climate change and greenhouse gases are the acid rain issue on steroids, and I think that's a really telling lesson that we learn from these kinds of studies.
Thank you for that, Ivan. And I'm sorry we won't be able to take other closing comments from folks, but Aaron has a few reminders for us. Everybody out there, you should come to the field tour on Friday. If this little taste from an hour today wasn't enough for you, we'll have a lot of fun in the field. So Aaron, I'll turn it over to you for wrap up. Thank you, everybody.
Yeah, thank you. Thank you, Amanda, and thanks for all our co-presenters. I really just want to highlight Bear Brook as a unique asset to our state and the importance of this long-term research. You saw Amanda's background that was from Howland Forest. Maine has a ton of these unique assets that I think really tells the important story, and we're kind of on the front lines for the effects of climate change, particularly when it comes to hydrology, as we think about the snow and rain events. So again, I invite everybody to join us on Friday. It's going to be a nice sunny day. We'll actually get out on the ground, see some of this infrastructure, talk about the research that Sean highlighted, and really learn about how managers like Mike or Jeremy try to take this into practice. But for now, thank you, everyone. We'll be in touch on details. Those can join us. And if you want to reach out for Meg, there are a few spots available for the field tour. So thank you, everyone. Stay tuned. And if not, we'll catch you on March with our next FCCI event. Thank you and happy holidays.